Welcome back, students. In this class we continue Introduction to Trigonometry Chapter 11 Exercise 11.4. So in the previous class we were solving the fourth problem. We finished two sub problems in the fourth. Now we continue the third one. So here third problem is secant a plus tan a into 1 minus sin a is equal to 4 options are given. So we have to solve this and find out the correct answer. So first step here is, we know that is secant a is equal to 1 by cos a. So this we know, just we have to substitute, and also here tan is there. Tan a is equal to sin a by cos a. So now substitute, write the problem here. Secant a plus tan a into 1 minus sin a. So now substitute for secant is 1 minus cos a plus tan is sin a by cos a into 1 minus sin a. Now we have to multiply this. So 1 minus sin a into this and 1 minus sin a into this. So we'll see here, that is cos is common here. So first we'll see 1 plus sin a by cos a, then 1 minus sin a. So what we get now, 1 plus sin a, 1 minus sin a will get. So now 1 plus sin a into 1 minus sin a by cos a. So this can be written as 1 minus sin square, which can be written as 1 minus, that is we have the formula a plus b into a minus b is equal to a minus b square. Now a square minus b square. Okay. Now 1 square means sin square a. Take this one as a and this one as b. Then a square minus b square by cos a, which is equal to, so 1 minus as we know, 1 minus sin square a is equal to cos square a. So substitute this here. So 1 minus sin square a is cos square a by cos a. Then cancel 1 cos. Finally we'll get cos a. So what is the option? That is option D is the correct answer. So take this. Now we move on to the fourth problem, that is 1 plus tan square a by 1 plus cot square a. So which is equal to, the 4 options are given. Similarly here we'll see what are the data, what are the formulas or we have to use. That is 1 plus tan square a is equal to, we can use this secant square a, first thing, and also 1 plus cot square A is equal to cosecant square A. We can use this one, and also we have secant A is equal to 1 by cos A, and also cosecant A is equal to 1 by sin A, and also we can use tan A is equal to sin A by cos A. All this we have to substitute here. Now take the formula, that is 1 plus tan square A by 1 plus cot square A. So here see 1 plus tan square can be replaced by secant square A. So 1 plus cot square is cosecant square A. So finally secant can be written as secant is equal to 1 by cos square A. So 1 by cos square A. Similarly cosecant is 1 by sin A, that is 1 by sin square A. So finally we have to multiply. So 1 by cos square A into this goes to numerator. When we simplify, sin by 1 it will get. So now we are getting sin square A, sorry I have written theta, sin square A by cos square A, which is equal to what? Tan square A. So which is the option correct? Option D is correct, which is equal to tan square A. So this is the solution. Carefully use all these things and substitute. So next we move on to the fifth question. Fifth question is, prove the following identities where the angles involved are acute angles for which the expression are defined. Cosecant theta minus cot theta the whole square is equal to 1 minus cos theta 1 plus cos theta. So cosecant theta is there, so it is equal to 1 by sin theta. Then cot theta is there, cot theta. So first see what are there, just write down the simplified form first, and then cos theta by sin theta. Then sin square theta is equal to 1 minus cos square theta. Then see, we'll start substituting. That is cosecant theta is 1 by sin theta. Then cot theta is equal to cos theta by sin theta the whole square. Whole square. After this, now we will see, write separately. Since there is denominator common, we can write like this: cos theta the whole square by, since sin is common, like this, sin square theta. Sin is common, denominator is common, 1 minus cos square theta minus. Since this one is 1 minus cos theta the whole square, we can write it as 1 minus cos theta into 1 minus cos theta by sin square theta can be replaced by what? 1 minus cos square theta. So this cos square theta can be written as, so 1 minus cos theta into 1 minus cos theta by 1 plus cos theta 1 minus cos theta. So this cancels. So as we know, a square minus b square is equal to, as we used in the previous problem, a plus b into a minus b. So this cancels Then we have 1 minus cos theta by 1 plus cos theta. So therefore LHS is equal to here RHS. They are given. See, 1 minus cos theta plus 1. We equate this to this. So both the LHS is equal to RHS by simplifying. So after this we move on to the second one. Second problem. Cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 secant A. So 2 secant A is first. What we have to do, we'll just cross multiply. Cross multiplying, we get cos square A plus 1 plus sin square A. This symbol if I use means cross multiplying. So just write down. Then the denominator write down 1 plus this, multiply, and we should write what are there. 1 plus sin A into, nothing is common, so we have to write as it is. After this cross multiplying, next step is apply for this A plus B the whole square, where we can write A square plus B square plus 2AB. So this one. So cos square theta write as it is plus 1 square plus sin square A plus 2 into sin A. By write out the denominator as it is. That is 1 plus sin A into cos A. Now we continue in the next. We'll continue here. I'll write once again where we stopped. So this was cos square A by applying A plus B whole square, cos square A plus sin square A plus 1 plus 2 sin A. So denominator was 1 plus sin A into cos A. So now we have to apply sin square A plus cos square A is equal to 1. So here take these two and apply sin square A plus cos square A 1. So 1 plus 1 plus 2 sin A by 1 plus sin A into cos A. So after this then add these two. Add these two, we'll get 2 plus 2 sin A and 1 plus sin A into cos A. So after this take 2 common here, 2 common, then remaining is 1 plus sin A by 1 plus sin A into cos A. So sin A cancels. Finally we get 2 by cos A. So we know that the secant A is equal to 1 by cos A. Finally 2 is there, just write 2 secant A. So this is the solution, that is LHS is equal to RHS. So this is the solution for the fifth sub-problem. So now we move on to the third sub-problem. So what is the third sub-problem? that is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus secant theta into cosecant theta. So LHS is equal to RHS, we have to prove, that's all everywhere. So we use tan theta, I'll write is equal to sin theta by cos theta. So apply here sin theta by cos theta by plus here cot means, as we know, cot theta is equal to cos theta by sin theta is equal to cos theta by sin theta. 1 minus cot theta, again we can write it as cos theta by sin theta. So 1 minus sin theta by cos theta. So now here cross multiply this, leave as it is, cross multiply sin theta by cos theta by sin theta plus here cross multiply, then sin theta minus cos theta by sin theta. Next cos theta minus sin theta by cos theta. Now we have to just multiply these two separately and these separately. So I will take this part first, sin theta by cos theta into sin theta will go to the numerator. So sin theta by, will get this one sin theta minus cos theta. Similarly this side, this whole thing is equal to here. I will take this whole thing. So this is for working or writing any formulas. So we'll see this same thing, cos theta by sin theta into, again cos theta goes to numerator, this one goes to numerator, by cos theta minus sin theta. Then next is sin square theta, sin square theta by cos theta into sin theta minus cos theta. The whole thing plus here also cos square theta by sin theta into cos theta minus sin theta. Now we'll just multiply only one thing, this with this and this with this, multiplying. So we'll get sin. So when the symbol I use here, that is multiplying or cross multiplying. So here only one we are taking, sin cube, sin is common, sin cube is there, then cos, here cos cube is there. Then when we change the sign, this and this we have to make it common. So we can change the sign, then this becomes minus. We are changing this. So then what are the common? Then we will get the common things. So common things will be what? Cos sin, cos minus sin, or sin minus cos. So finally we can write as cos theta into sin theta. So this thing is, and this thing is common, and since we have changed the sign, we can write it as both are same, sin theta into cos theta, minus cos theta. Now we have this formula, that is x cube minus y cube is equal to x minus y into x square plus y square plus xy. We can use this to this denominator. So now, this one, numerator. See, apply this formula to numerator. So what happens now? Sin theta minus cos theta cos theta and sin square theta plus cos square theta plus sin theta into cos theta. X square y square x into y. So finally cos is, write down the remaining thing, cos theta into sin theta, this is into, and sin theta minus cos theta. So sin theta cos theta, this one cancels. So what are the remaining here? And remaining also sin square theta plus cos square theta is equal to 1. So replace this by 1. So remaining 1 plus then sin theta into cos theta we get. So write down the remaining cos theta into sin theta. So finally we have to expand this thing. So expand this, we'll get 1 by cos theta into sin theta, sin theta here. Expand this, 1 by cos theta sin theta plus sin theta cos theta, because further simplification is possible, therefore cos theta into sin theta. We are just expanding, that's all, sin theta. So now whole thing cancel, cos sin. So remaining is 1 by cos theta into 1 by sin theta. So what is 1 by cos theta? So we know 1 by sin theta is equal to what? Cosecant theta, and 1 by cos theta is equal to secant theta. So replace it here, therefore 1 by cos theta will be what? Secant theta, and 1 by sin theta is equal to, so I left out this 1, so this is 1 plus 1 here. So secant theta, 1 by cos is secant theta into 1 by sin is cosecant theta plus 1, because these things cancels here, plus 1. Therefore finally LHS is equal to RHS. So we have the last one in the fifth subproblem. We'll solve this one. That is the fifth subproblem 4. So this is 1 plus secant A by secant A is equal to sin square A 1 minus cos A. So we know secant A is equal to 1 by cos A. Therefore replace it now, 1 plus secant means 1 by cos A by secant A, right, as it is equal to cross multiply, so cos A plus 1 by cos A. By secant again we can replace it as 1 by cos A. So after this just cross multiply, just simplify cos A plus 1 by cos A into cos A by 1. Therefore finally we will get cos A plus 1. Now we have sin square A plus cos square A is equal to 1, or we can write as sin square A is equal to 1 minus cos square A. So this should be in 1 plus so we stop at this. Next we will take this one. So this is for 1 by secant A, 1 plus secant A. Now we will take the other side, sin square A by, so this answer, one answer we got for this. And we will make equate LHS to RHS. We are now taking sin square by 1 minus cos A. So after this, for sin square A, we will replace this one, that is 1 by cos square A by 1 minus cos A. Now we can apply this, what, A square minus B square is equal to A plus B into A minus B. So now here 1 plus cos A. So this one is for, we will apply this formula for this. So it can be written as A plus B, A minus B. So 1 minus cos A, 1 plus cos A by again 1 minus cos A. Cancel these two, so we are getting 1 plus cos A here. So we took both and we proved it. LHS is equal to both the sides we took. Therefore finally LHS is equal to RHS. So this is the solution. We completed 5 questions in the exercise 11.4. If you have any doubt, comment me. Subscribe my channel, share and like all the videos. Thank you.